Started. You guys want to have any conversations? The hallway is nice and comfortable, lots of tables, chairs, and leftover snacks from the last meetup. You guys want to go outside? All right.
Hi, so my name is Timothy Jacobs. I am a developer at iThemes. I work on the iThemes security plugin. Today I'm going to be talking to you about JSON Schema and the WordPress API. I'm curious, who here has heard of the WordPress REST API before? Awesome. Who has ever used an endpoint before, like getting posts, creating posts? And who has written an endpoint before? Okay. So what we're going to cover today, we're going to talk about the basics of JSON Schema. This is how you define your formats for API endpoint. We're going to go over some complex schema examples. We're going to talk about user interfaces and front-end validation, and then we'll give a brief demo. If at any point things start to get too complicated, I will make a good effort to kind of slow down at points and raise your hand if you have a question. I'll try to get to it. So as the JSON Schema website describes it, JSON Schema provides a vocabulary that allows you to annotate and validate JSON documents. So how does this relate to WordPress? WordPress uses it to document the request and the response format for all REST API endpoints. WordPress uses a subset of the schema, and it uses it to validate incoming API requests and return errors indicating why the request is invalid. WordPress also extends the schema to support limiting response data to only parameters in the requested context. This is helpful for things like the post password field. You wouldn't want that to show to the public. WordPress defines that this is something that's only available to people who can edit the post using the JSON schema. So let's take a look at a super basic parameter described using JSON schema. First, we have the title field. This is basically a human readable label for what this field is called. Next, we have the description field. This is developer documentation. It describes what this actual parameter represents. Next, we have the type. This field is a string type. We're going to go over all of the different types in a second. And then you can see here the context. So we're defining view and edit as the context that this field will show up in. The default context is view, excuse me. So types are the fundamental building blocks for constructing an entire schema. There are 7 types that can be expressed using JSON schema. We have Boolean, integer, number, string, array, object, and null. So let's take a look at the Boolean type. Booleans express whether a particular value is on or if it's off. This corresponds to what you think of as true or false in PHP. And because PHP does not actually support passing real Boolean variables as request data, WordPress will accept the string values of true and false. So you can see an example here on the post endpoint. This is the sticky parameter, the sticky field, and it says whether a post is sticky or not. And it's described as a Boolean type. Next, we have an integer. These are integral numbers that don't have a decimal point. Again, because PHP really only accepts strings and arrays of strings and regular request data, we can pass it a string form of an integer, and WordPress will convert it for you. This is useful for things like WordPress model IDs, users, comments, posts, pages, etc. Or you can use it for something completely different, like the remaining inventory of a product. A number is a decimal point that a number is a number that has a decimal point, or it can be an integer. So this means that you could accept 1.1, 1.0, as well as just 1. For example, this can be used to describe the weight of a product or a latitude and longitudinal position. And again, PHP, because it only accepts strings, will auto-convert it to float if it matches if it's float-ish. Next, we have strings. These are probably your most common data type. They are not constrained by any length. They could easily be 3 or 4 or 5 characters, as well as the entire post content. It could be just digits, for example, a credit card number, which you should treat as a string, not a number. In this example, we have the post password. It's a string, and you can see here we only define the available context as edit. If you're thinking back to the defined formats, you might be confused. How do you express things like dates or emails, more complex data types? Parameters that have a string value type can use the format keyword. This is useful for data that is stored as strings but have additional formatting requirements. These are formatting requirements that might be consistent across different implementations, and there's something that you can actually say, this is a date time, or this is a URL, this is an email, IPv4 address. This, for example, is the date GMT field on the post endpoint. It has a format of date time. It's important to note that string formats can only be used for strings. You can't use a string format with a number or anything else. Next, we have the array type. This is representing a list of values. The actual type of each value is defined in the items property. So this is where we define tags on the WordPress post endpoint. We can see that as a type of array. We can see that the items, every single item in there has to be an integer. We can see it expressed because it says type : integer. Next and lastly, all I'm going to be covering is object. This is where you have multiple name values.
Yeah, multiple dimensional arrays.
We'll get to that kind of later. You'll see an example of it, but essentially every single bit of JSON schema can be nested indefinitely. You'll have more performance trade-offs as you nest down and down and down and down, of course, but you can do pretty much anything like that. So objects are multiple name values. Each object property has its own definition, its own schema constraints. This is what you would think of as an associative array in PHP. WordPress will convert it to an associative array, but it could also be an STD class. We see here the content field. I've omitted some common things like context, which can actually be defined for both the raw, the protected, and any other properties. I've left out here so we can try and get these things to fit on the slide, but those can appear inside nested objects as well. We can see here that we have the raw property first. This has a type of a string, and in WordPress, this stores the raw, unmodified, unprocessed post content. Short codes, for example, are not processed at this point. And this is a context-only edit, of course, because you don't want the general public to be able to see your unformatted content. Next, we have protected. This is a Boolean field. This is indicating whether the post is actually protected by a password or not. There is, again, a rendered form here, which is very similar to the raw field in terms of actual JSON schema constraints. But it is marked as read-only, and I omitted it really for clarity. So what would it look like if we put all these individual JSON schema pieces together? This is what it would look like. I've, again, omitted a whole lot of properties because there's only so much space on the slide. So first we have $schema. This is a very important keyword that defines the version of the schema that is used. WordPress uses a combination of both the version 3 of the specification as well as version 4. Version 6 is the latest version of the spec, and version 7 is actively under development. Excuse me. Next, we have the title. In most contexts, this would be a human-readable label for the schema. In WordPress, however, it refers to the object slug. So post, page, comment, all lowercase, not translated, not uppercase P, post, etc. The rest of this top-level definition is all about validation constraints. So this is specifying that that the actual WordPress post endpoint is a type of object. You'll get objects back, and it has listed properties. So you can see here, this is an example of kind of the infinite nesting of JSON schema. We have a property, and then if you remember from before, we have nested properties underneath this. So what would making an API request look like? Well, we would make a request to an endpoint, wp/btu/posts, and we can send data as either a request body as form data. This would be what you're getting if you have an HTML form, or as JSON. So you can see an example here. We're trying to update a post. You can see that based on the fact that we have the method parameter put, and that we're contacting a single post endpoint, wp v2post1, where 1 is referring to the post ID. You can see in the body that this is an HTTP form. This isn't a pre-JSON encoded blob of data. You can also see if you're eagle-eyed, this is passing a status of publish. Publish is an invalid status. So how does WordPress handle it? WordPress will give us an error back. It will specify that we have an invalid parameter, and it'll give us some more detail about that. The first thing there is the response code. This is a top-level general descriptor of what the error is. This error code can be consistent across endpoints, and it usually is. So for example, in a permissions context, we would issue an error that says REST cannot edit. as opposed to REST cannot edit post, REST cannot edit page, REST cannot edit comment, etc., etc., etc. Next we have message. This is summarizing the error response. It's not very descriptive. You probably shouldn't be using it if you're showing your users what the error occurred. Next we have data.status. This is the HTTP status code that is returned from the server. In our case, since we gave an invalid parameter, invalid request data, WordPress will give a 400 response code. Next is data.params. This is a list of every invalid parameter that was included in the request, and a corresponding message indicating why that parameter is invalid. And so we can see that here with multiple errors. We're trying to update a post with a status of published. It's not a valid status as we covered before. And we have an author, which is John Smith. Of course, the WordPress Post API deals with authors that are IDs. So WordPress will give us two errors here, that the status parameter is invalid and the author parameter is invalid. So how is this validation performed? Controllers provide to WordPress a JSON schema. This is a schema that WordPress uses to validate the request data against. It's important to note that this request data is validated before the controller callbacks are ever executed. We can see an example of this here. This is how a slimmed down version of how WordPress registers the post endpoint. There are two important things to note here. We have the schema option, which is global, and the args option. The args option is built from the schema, and the actual schema document is provided as a callback with getPublicItem schema. The actual args are what WordPress uses to perform the validation. You could theoretically provide arguments that don't match your schema at all, and it'll be fine for WordPress, but that's not advised for obvious reasons. So for going back to our post status example, we have a status, a description that says this is the status for the object, it's a type of string, and here we're defining an enum. This is a list of allowed values. So we have publish, future draft, and in private. And so because our value didn't appear in there, WordPress will give us an error. All good? Okay. So let's take, for example, a customer contact. Here we're laying out the basics of what this object might look like. We have a first name, a last name, we want the customer's phone number, and an email address. For all of these are string properties, so email has an additional constraint of email as expressed as a string format. You might think that phone would have a defined format, but there's not one that exists, though you're more than welcome to extend JSON schema to support any additional formats you want.
Are the formats predefined in the schema, or is this something that you're putting as just a value for the developer?
Sure. There are a set of formats that are defined by the actual specification that most validators should support. It is important to note that not all validators do, nor do they necessarily have the exact same semantics, though they're supposed to follow the relevant RFCs that say this is what an email looks like.
Can you define your own format?
Yes. So this depends highly on what validator you're using. For the front-end validators that we'll talk about a little bit earlier, it's very easy to define your own format. For a more fully featured JSON validator for PHP, which would arguably be the most important part, right? Because you want to make sure the data is actually valid on your server side. It can be a little bit more complicated, but it's still totally doable, particularly by the library I'll be showing you. Anyone else? Yes?
So I read before,
Sure.
in the title field, it says contact. Is that, like, I thought that those were more like post types or...
Yeah, so in this instance, it should probably be better described as a customer. I think I reworked this example a couple of times. It should have a title of customer. But so in this instance, customer, in let's say, for example, WooCommerce, customer would be expressed as customers are kind of models. You can think of them as each having their own record in their database. And while it's not particular to post type as in post page, whatever custom post type you want, it would be more applicable to a comment, where the comment endpoint, for example, has the title of just comment. Now, what if we want to support multiple email addresses for a customer? Important to note, your link here, the other things haven't gone away, but I'm just focusing on the most important parts. So here we change the email parameter a bit. We change it to emails. It's best to indicate that this actually is an array. we specify that the type is an array, and then we specify the format for items. Here you can see that the constraints for each item can be more complicated than just a type. Here we're expressing that the type is a string and it has a format of email. But different emails probably have a different type associated with them. We might have a work email or a personal email. And so again, here you can see how JSON schema nests itself. We're saying that each email is actually an object. So it's an array of objects, where we have a property of address, which is the actual email address, and then type, which is a string, and it can be one of work or personal. However, we might say that the address type, while it would be helpful, isn't necessarily required information. If it's not required information, we don't require it from the user. So here we specify what the required properties are. This is an important distinction between version 3 of the spec and version 4 of the spec. WordPress uses a hybrid of the two. WordPress uses the version 3 syntax for describing required parameters. What that would mean is alongside type, string, format, email, we would say required is true. In version 4, this was changed. The reason that WordPress uses it, it makes more sense for adding things to a schema, like registering additional fields. Though if you're developing custom endpoints, I would recommend to either use version 4 or to use both. We don't want duplicate emails for customers though. So what we can do is we can use the unique items keyword. We set it to true, and this specifies that every single object in this list must be unique. However, this would have a problem. This would allow a user to submit the same email address, but just with a different type. As far as I know, there's no succinct way to express this constraint using JSON schema. And so while you should use JSON schema wherever possible to perform your validation, you should make sure to have additional validation on your server where appropriate. And so putting it back together again, we'd have something like this. Another piece of vital information with a customer would be their address. Where do they live? Where do they want products shipped to? So how would we define this? Well, we would probably have a list of a few properties: address 1, address 2, the zip code, city, state, and country. The address 2 isn't required, so we don't list it as one. But you might spot a problem here. Do we want to use the country name, or do we want to use the country code? It's not very obvious in the schema which we should use. And using a country name can lead to errors with different names for the same value. One user could submit United States, the other could submit United States of America. We could use the enum property here to define a list of all the country codes that are allowed as values. But then what about country labels? How do we define those? Version 4 of the JSON schema spec has a solution for us. This is called the one-of keyword. It specifies that a value can match exactly one of the provided schema definitions, no more, no less. Here we have a simple property that I'm just calling prop name. It has a type of string. The one-of keyword is a list of individual schema constraints that the property must validate against. In other words, each object here, each item in this array, must itself be a valid schema constraint. So let's see that in action. Here we have we have the title is set to United Kingdom. This provides our human readable label. And then we use an enum to specify that only one valid value is possible, GB. And the same thing repeats for the United States. This, though, still has a simple data input. We just have address 1, 123 Main Street, and country is set to US.
So how would you support the United States of America in here? Would you add another row?
Well, so you could. It would be perfectly valid to have United States of America as a separate option, though one of the advantages to having United States as a title is that you can build a UI from it. So you can take this information to build a drop-down that has United States. And if the customer sees United States, that's probably good enough for them. In version 6 of the spec, this becomes more succinct. We can use the const keyword. This indicates that only one value is supported. It has many other applications, but it works great here. What about stakes, though? The same issue applies to stakes. We want to ensure that the correct name is used. While it's probably less likely that someone has New York and knew something completely different, maybe we want to make sure that capitalization is correct. Either way, having duplicate states for the same value could be a problem in the database. This is a harder problem to solve because states depend on the country that is selected by the user. However, we can take this one-of concept and apply it at a higher level. This is introducing the all-of keyword. It specifies that the value must match against all of the schemas provided. Here's a bit of a contrived example. We have a property underscore prop name. It has a type of string. That first type is redundant. I probably should remove that. In all of, however, we're specifying two schemas here. We're specifying a schema that the type is string, and we're specifying another schema that the format is email. The only way this is valid is if we're providing a string email address. So you can see that it has to go through every single schema and ensure that the value is valid against every single one of those. It's easy here to shoot yourself in the foot. You could easily say that the type is integer, and it has a format of email, and that can never validate. So this is what it would look like if we were going to define this for states and countries. At the top, we have our first subschema. This is a list of the common properties. I've omitted a couple for brevity, but these would be your fields in common: address 1, address 2, etc. Next, we have the one-of property. This is where we're actually listing each specified country as its own schema and their associated states using an enum. You can see this more clearly here. So specifying that the state has New Jersey and New York. It has the other 50 examples. We're expressing that it is belonging to a country that has a value of US, a title of the United States. And another thing to note is that each of these is properties. These are all nested under properties. Because we're defining multiple properties in this one-of constraint, each one of these has to itself be a valid schema. So that's why we leave it like that. Because state itself isn't a keyword, country isn't a keyword, properties is the keyword. You can also see here that not every single one of these has to be identical. We have the state, we have the country for United Kingdom, but as far as I'm aware, they don't have a list of defined states. State usually doesn't actually mean much, as far as I'm aware. So for here, we just set it to a string and put accept anything. And now again here, we don't have labels for the states. But we can take this a little bit further, which I'm not going to show because it gets lengthy, and define the states with the associated labels as constants using one-of. For most validators, this will be performant. For the validator that I'm showing you, all this is pre-compiled. And it'll be fine, though, ugly code. And you probably want to generate a schema like this dynamically. So what about billing and shipping address? This is already a lengthy schema. We don't want to include it 2, 3, multiple times inside another JSON schema. To accomplish this, we can use something called the ref keyword, $ref. This allows us to reference another schema instead of defining it again as a duplicate in line. We can reference schemas that exist in the same document or in another document entirely. This uses what's called JSON pointer notation, which we'll cover in a minute. So we can take an example here. We have our schema. This is the top level schema, our version. Here we have a new keyword. This keyword by itself doesn't actually have any semantic meaning. It's merely used as something that makes it easier for you to look at different schemas by different authors. Definitions is something that people should use in common. So when we get to our billing and shipping address fields, we use the ref keyword to reference this schema. The hashtag defines the root of the document. Then we go into definitions, which matches definitions, and then into address. We can also have an external reference. This can be another URL completely. This would be particularly helpful if, again, an address might seem something that's fundamental to an e-commerce application. You might have it for customers, you might have it for transactions, you might have it for the store address, things like this. So we can reference it. This is a made-up URL. It's not going to work. And we just point to the actual where that schema would be found. On the server side, because you have knowledge of all the schemas that exist, you can have these set to be pre-looked up so that it can easily associate a schema with this URL corresponds to this, and it'll find it very quickly. On the front end, you would have to dynamically load these. Things like the JSON schema validator I'll show you for JavaScript allows you to asynchronously fetch your schema. And I'll go through and find all these references. So how does this JSON pointer notation work? We use it to refer to a position in a JSON document. The / character is used to access properties on different levels. The / character is used for everything, be it numbers or strings. In JavaScript, you might be familiar with just JavaScript object path notation, which uses a combination of dots and brackets depending on type. This is much simpler. When used with JSON Schema, we extend it to provide that the hashtag symbol points to the root or the start of the document. That's the part of the $schema, title, etc. So what are some examples of just accessing things with JSON pointer? Here we have a object-defined emails, email and type. Hashtag /emails refers to the entire array of emails. Hashtag /emails/1 refers to the entire record. The arrays here are 0 index based. So the first one is in fact 0, the second one is in fact 1. If we wanted to get just the email address, we would do hashtag emails/1/email. So let's take this back to WordPress. WordPress only supports a subset of the schema constraints that I showed you. The object type is not supported, nested objects won't be validated. All of and one of keywords are not supported either. Additionally, JSON Schema provides a vast array of many helpful keywords that aren't used by WordPress core, so there's not a WordPress core implementation for this. But we can still use it. I wrote a library that bridges the gap between the WordPress REST API and the full JSON Schema specification. It uses Just in Rainbow JSON Schema package. It performs validation according to version 4 of the spec. You can find it there. Usage for this is very simple. You just shade it, you provide it some strings as well as your REST namespace. It'll go through, find all the schemas, everything. So what about using JSON Schema on the front end? Before I get to that, any questions? No. JSON Schema is built to be portable. It is usable in many different environments. There are validators for Java, JavaScript, PHP, Python, etc. You can use it in different environments on the server in the browser. And you can use it to drive front-end validation. This will give your users a faster experience. You don't have to wait for them to hit your server and then come back to figure out what's wrong with their input data. And you can partially seed or even generate the entire user interface. This is the JavaScript-based JSON schema that I would recommend. It's a very fast NPM package that works both in Node and in the browser. It validates according to JSON Schema, spec version 4 or version 6. It allows you to use custom error messages using its AGV errors package. If you're going to be presenting this data to the front end of your website, you want to make sure that it's error messages that are not super developer oriented. You can find it there. You can just Google it as well. What does the usage for this look like? We import AGV, and we have to do a little bit of configuration so that it can work with the version 4 of the specification. We're essentially importing the meta schema document, and we're setting it as the default meta schema. Here we compile the schema. This is const validate equals agv.compile. This schema compilation is done once per schema. It's what makes this validator so fast. It converts what would be a tedious process of nesting levels, keeping track of things, going back and forth, into just a series of if statements. Once we have a validator, this can be reused multiple times. We check if the provided values are valid. If they're not, we can print the errors. They're found and validate.errors. They're not returned as a separate object for performance reasons, but you can retrieve it from there. The error format returned by here is fairly straightforward. It differentiates from WordPress in that WordPress will return only one error per property. This is a problem because there can be multiple things wrong with the property. So AGV takes a different approach. It defines just a list of all the problems, specifies the path in the data, and the path in the schema where it failed at. You can see in my first example here, we have a random property that has a max length value set. This defines the maximum length of a string. And you can see the default message that's generated is quite unappealing, should not be longer than 5 characters, presenting that to your user, probably not the best of ideas. You can see in the second example what this would look like with a custom error message that is defined in the schema itself. So how would we use this to generate a user interface? JSON schema can be used to generate user interfaces in their part or in entirety. There's official extension to JSON schema being developed, very, very early stages, that would be concerned itself more with the user interface part, but it's still possible to get a whole lot done with the current state of things. This is a simple form. Well, not so simple, actually. This form is entirely generated from the schema. There's some things cut off. I'll be showing you a little bit of the demo more later. We use the title property for field labels. We can use the type and format keywords to help enhance the UI, show number inputs where appropriate, show date time inputs where appropriate. One of can be used to express conditional fields as well. So the example at the top there, we have username and password versus application password. If username and password is selected, it shows 2 fields that say this is the username, this is the password. If application password is selected, there's only one thing that's selected. We can also generate dropdowns from enums or from one-ofs or constants. And we can use an array for repeatable fields. That's cut off at the bottom there, which is a list of fields. We can also simulate WordPress list tables. This displays a collection of items that are represented. You can support row actions. Things like edit, delete, quick edit even, can be built from the JSON schema. It utilizes the allows header. This checks what HTTP methods are allowed for the current authorized user against an endpoint. So if a user does not have permission to edit a post, they won't see the edit button. This requires a pre-flight request for each item, but is only a head request, so it's not too horrible on performance. You can also implement custom row actions and tailored edit experiences using the Hypermedia specification, which we'll get into in a second. We can even automatically generate search and filter forms based on the collection parameters. We also support pagination through the use of first, prev, next, and last header links that WordPress sends. Here's a basic example of that. That's entirely generated from the schema. We have a search form at the top where we can specify that only lists that match a certain string, only ones that have been updated a number of times, select the number of levels, select whether it's completed or not, excuse me. And that search form will go through all on-page base. You can also see how we develop the row actions. We have edit, quick edit. We can delete in line. We can mark it as completed in one click. And we can open up a form that is just meant for renaming. We also support to quickly create or quick create, and then pagination. All this can be generated from the JSON schema. What are the limitations here? The context query parameter that we talked about way in the beginning for limiting what fields show up in what contexts, it can help us to limit the fields displayed. On a list table, we don't want the 25 properties of the posts, but it really isn't sufficient for all cases. You might have noticed there we still have the list ID column. We also can't really easily define a column order. It just follows the order that is defined in the schema. We're also using the description keyword for inline user help. Typically, this is for developers. Additionally, specifying desired inputs can be difficult. For example, a password input or a text area input. That's not so simple to do because there are no actual additional constraints that go along with what a text area is or what a password is. Hypermedia is the engine of application state. It has a nice acronym. This is a really awesome, still in kind of progress, principle of REST APIs that provides a way for a client to navigate to different endpoints programmatically. JSON schema extends upon this concept through its use of the hyperschema/hypermedia specification. And it has link relations with defined semantics, so a client can interpret them without specific knowledge of the application. So for example, the search form, that's a little small, I apologize. We have a rel, which specifies the link relation of search. This tells the application that it can treat this as a search field. We're then defining href, which is basically a URL, and it's templated, which allows us to insert parameters there. We use the href schema object to define what fields we want to show up as options in the search form. We can also do custom actions. Here we have a rel that is set to edit. This indicates that we're editing the specified item. We have it as a title that says complete. This would indicate to the user that clicking this or triggering this form would complete or mark the list as complete. Here we use the submission schema property to specify a fixed amount of data. The UI schema, this is all to do with the UI. WordPress won't use this for validation, so we can use v6 keywords like const here. The front end can determine that all the properties inside of this submission schema are fixed values, so it knows to the user that it doesn't have to prevent them with a form. It can just perform the HTTP request. We can also have tailored edit forms. We have another relation of edit. We have a title for rename. We're specifying a ref that specifies to that given list. It says to extract the ID parameter. And we just have a single input, list name. And that's the only thing that will show up. There is a list of registered link relations that have, defined semantics to go along with them. For example, next indicates that the given URL points to the next page of collection. Prev goes to previous, first page, last, etc. Search is a link relation that indicates the URL is a way to filter a specific document or a collection. We have edit. This indicates that the current item can be edited at a given URL, and custom relations are also supported. This can be any URI. WordPress uses api.org/term to define that the given link relations are for terms. This allows you to have a more general interface that deals with categories, tags, any other registered custom taxonomies without having to know they exist, but just knowing that they are terms. Many more than just these I've listed here are available online. You can easily Google search for them. We also have the schema types that we touched on a bit. A link can, does not have to, have an associated schema. A ref schema defines the parameters in the URL. This is useful for GET requests. Target schema defines the response format. There isn't much that is very immediately helpful for that, but it can help to reduce additional HTTP requests. If you're saying that the resource at a given URL has a schema, that means it doesn't have to go and fetch the schema as an additional request. And then submission schema defines the request format. We lastly have here URI templates. These define the ways that variables can be applied to a URL. It supports both single parameters as well as an array or a list of parameters. For example, we saw earlier ID is replaced with the ID property for the values. Search updates and types. The question mark determines or defines that this will become a query argument list. Search is equal to the search string value updates to 1, type to all. So what possible use cases are there for automatically generating UIs based on schemas? I think this works particularly great for settings pages. They're not something that particularly needs a super awesome user interface most of the time. Most things are fairly simple. I think back-end widget configuration forms is a great use case for this. It would be helpful in unifying widget API experiences, both in the customizer and in the widget forms, as well as any other contexts. The same thing goes with meta boxes. This would be great for the new Gutenberg editor, if you're familiar with that. I think there are interesting applications for plugin extensions. Imagine WooCommerce, for example. WooCommerce, you can define multiple different product attributes, tabs that show up in the edit product form. As it currently stands, this means that if you want to have an alternative interface for editing with WooCommerce, you would have to integrate for each specific add-on separately. If add-ons could provide a schema that says these are their fields, you could build user interfaces for Calypso, for your own mobile app, or your own WooCommerce experience. This is also useful for just basic CRUD dashboards, where there's not a particularly interesting UI that needs to go along. And for where UI is more of a concern, you can use simply just schema-based forms and small sets. That might be a larger part of a single-page application. Get to the demo in a second, but so we don't have to switch back to slides. I hope this isn't all great. My name is Timothy Jacobs. You can find where I work at items.com, and I will be posting the slides and a whole bunch of code at my website today or tomorrow. So let's see if this will. Oh, that's ugly. One second. So this is the example that I showed you earlier. This is in its entirety being generated from the UI. We're defining a couple of extra things. It's bigger. Page titles, for example, here are defined when you're registering the route. Typically, if we use the title field for its proper semantic reasons, we wouldn't have to do that, but as a workaround, we specify when registering the route. So you can see here we have a list of items. You can see the row actions. We can do pagination, and it'll go through automatically. And on the same page, it updates the URL, etc. This is built with Vue.js. I'm just going to prove that this is actually possible. It's not particularly a JavaScript-focused talk, so I'm not going to be going into the exact specifics, but I'd be happy to answer any questions. So we can see here we have, this is not like the new aspect ratio. So you can see here, we clicked rename and it opened up a form specific for this. If I was a better designer, it could open up as a traditional quick edit menu in WordPress that you might be familiar with. So we can set this to a new name. Hopefully it'll work. There you go, it updates. It updated the update count, things like that. Another cool thing is where links really come into play. So we're going to edit this list. You can see here there are some additional fields like due date that weren't showing in the table. This was because of they're listed as just to show up in the embed parameter, in the embed context, excuse me. This is a date time format, so we show a date picker. You can set a password, mark it as completed. We can also add new items. So this is multiple item support, and we can remove them. We can also, which I think is cool, this is how you can navigate through different endpoints and work your way through a more complex nested CRUD application. This is going to notes. So this is showing all the notes that might be associated with that list. And so this is a separate URL. It is defined as a link. We can add a new note here. Set the author ID. This is an example of defining a custom format. This is a format of HTML. In WordPress 4.8, we can dynamically instantiate TinyMCE. And the format also specifies a whitelist of HTML that will be validated server-side. We can then also go to a completely designated note form, set the author ID. Complex problem that I haven't figured out how to solve, and I think still is in the process of being decided if it can be solved, is ideally we would want this author ID, right, to be a list of authors, like a select to automatically search-based thing. This is difficult to solve. One typical thing you might try and do is use the ref keyword to point to the user's endpoint and specify that we want the ID parameter from there. And that semantically makes sense, but then you're just displaying a list of the IDs. How you can specify without having a user interface specific keyword, I don't know. It'll be an interesting thing to see if there's progress made there. This is notes for here in this contrived example are read-only, so it navigates us to a view-only field. We can also take a look at the settings. Don't look at the secret keys. This is, for example, the username and password. So here we're changing, we want to do username and password authentication, or we want to do application password authentication. We have a select, this is driven off of an enum, and we have our repeater fields, so we can add a new field. We can also have here, you can see how nested objects in array work. This is a nested field. We can save this, and you can see that there are errors. You can see that items can be empty. and we see another item, another error that says each item must be unique. And so this is an example of how you could define validation, use that validation in line. This didn't hit the server yet, and show it to your user. And that is all I have. Happy to answer any questions. Yes?
So in this view, I'm curious where the boundaries are between what you've done in view and what the actual PHP looks like. I'm
Sure.
seeing you using a hash URL to jump around, but
Sure. So I'm using Vue.js. It is a front-end framework. It has a router. What's happening is that the variable part of this page is that when the page is contained, you might be able to see it. This is local, so it feels even faster than it actually should be. But that brief second where there's nothing there, it's fetching the schema documents, it's parsing them, and it's defining routes in Vue.js, and that's that. On the admin, or the backend, excuse me, it's pretty simple. I don't know if that's even close to readable. We're defining the item schema here, the list schema. We have some helpers that I've written that could be extracted in something else that aren't dependent on the schema. This is essentially going through all of the default WordPress collection parameters and converting them into a search rel so we can automatically build a search form, things like that. The actual kind of implementation part is fairly simple. All these lists, another reason why it feels fast is that they're being stored in user meta. It's not difficult query for it to perform. So here I'm simulating pagination in search by just fetching all the records and going through them. If you connected this to a proper database layer, or WP query even, this would be way simpler. The actual retrieving and creating items is dead simple. There's no additional constraints that we need to provide here. All of the validation can be handled by JSON Schema, so we don't need to really have any logic here that has to deal with performing validation. Updating the item, deleting the item, preparing the item for the database. If you've made WordPress routes before, this should look familiar, but essentially there's not much complex logic here going on. Another concern here, we're just taking the input completely and piping it into the database. This might concern you that we have fields. Someone could insert a field that we don't want to be there. JSON Schema has support for setting additional properties to false. That means that any properties that aren't defined will be omitted. Does that answer your question?
yeah, actually.
I have tutorials for this.
So I have written a blog post at my website about the JSON Schema stuff that goes into a little bit more detail and covers essentially the first 2/3 of this talk. And I'd encourage you to look at that. For the UI stuff is really just something that I've been hacking away at nights and weekends for the last month. So there's not any user guides for this yet, but it's something that I plan on.
What's the editor that you're using?
PHP Storm.
Say again.
PHP Storm.
So I assume you guys are not using this now?
No. I think there are interesting applications that we could use it in. For example, our sync product. I think that would be an interesting way to extend support for plugins or for meta boxes, things like that. But we're not using it to drive anything. I'm working on a couple of personal projects that this was born out of. Yeah.
Does this work well with custom post types, or do you have to add support for them?
It works great with custom post types. There'd be a little bit of tweaking that you need to do, really that WordPress needs to do. WordPress registers fields, but they weren't thinking for good reason about what this would look like for a UI. So things like titles for each of the properties aren't defined. If you wanted to use it for that, you would need to define those properties. But it would be fairly simple to do. WordPress, if you set your post type to show and rest, it will generate all of the routes for you.
And what file do I go to?
This would be more complex than just one file. The whole JavaScript thing is just JavaScript, and it really has you could configure it using WP localized script in your functions.php or your plugin. The admin side would all be handled by WordPress, but the JavaScript, this is fairly complex. So the JavaScript, because it has to deal with nesting and things like that. Yeah.
And past custom post types, does it support custom tables?
So I've written, last time I gave a presentation here, last year I gave a presentation on custom tables in WordPress. I've written a ORM that kind of encapsulates all this stuff. In the context that I'm using, that I originally kind of inspired to develop this out of, is going to be using custom tables, so I plan to be able to make it easy to bridge the gap between the two. Because this works with any REST endpoint, if you register REST endpoints for your custom tables, it could work. Thank you.